We're looking now at the mechanism of electrophilic addition, and here we have an alkene, ethene. Now, the nature of double bonds is that you have a sigma bond, which is just between the two carbon atoms, that's where the electrons occur, and a pi bond, whose electrons are above and below the plane of the atoms. And because the electrons are above and below, you've got a high electron density there and there. That means that molecules that like to accept a pair of electrons, or molecules or ions that like to accept a pair of electrons, known as electrophiles, are keen to react with alkenes. So along comes an electrophile. Now, as bromine comes near the high electron density there, it pushes the electrons away from the upper bromine atom, which causes an instantaneous dipole. Just while they're close, there's an instantaneous dipole with the electrons pushed towards the lower bromine. This means that the upper bromine atom, now which is a bit short of electrons, can accept a pair of electrons from the double bond into its outer shell. Now, bromine can only fit 8 electrons in its outer shell, so this means that the other bond here has to break. And this leads to the formation of this intermediate. So, bromine, one bromine has joined, a pair of electrons came from there, it now forms a bond between the carbon and the bromine, so it's here. This carbon has lost the electron of its own that it was sharing with that carbon, so it's now positive. This bromine has gained back not only its own electron that it was sharing with that one, but also the top bromine's electron, so it's gained an electron overall, so it's minus. Next stage, the lone pair, or one of the lone pairs on the bromide ion, will now attack the carbon, and that will give you the end product, 1,2-dibromoethane. A couple of other things to note here. The bromine-bromine bond here is being broken in an unsymmetrical manner. Both the electrons are going to one atom. Rather than the electrons being shared equally, both the electrons are now going to the bottom bromine, and because it's both going one way, we call that heterolytic fission. Fission means splitting, hetero means different, and the two bromines are different in the sense that one gains both the electrons, the other loses both of those electrons. So that's an example of heterolytic fission. The other thing I want to point out in this diagram is the curly arrows always come from a pair of electrons. So whenever you draw curly arrows, they're coming from that pair of electrons, the double bond, in the double bond, they're coming from that pair of electrons in the single bond, and they're coming from that lone pair there. And that's true of any mechanism. You will see curly arrows, they have to come from a pair of electrons.